Okay.
All right, here we are trying all of this problem again in the short version, and we're putting it in this equation, and we put these numbers in here. We came out with 166 and rounds to also 2 sig figs 170. So
See, that's
we're
the
going
same
to stick
answer.
with the short version when possible.
As you can tell, the one on the right is a lot shorter than the one on the left. A lot more simpler.
All right, very good. Now, my warning to you. On your notes, when you still have your range equation notes, I want you to make this very important note. The range equation is only used when the projectile ends at the same height as it started. So, like if it starts here and ends here, they're both at ground level, same height. But if it's on a cliff, and I start here and I shoot up here, or if I start on the cliff and shoot down here, I cannot use the range equation. So, all right, make a note of that. Range equation used when initial and final height are the same. Initial and final height are equal.
What does that
Alright, I
face
put some symbols in so it would fit.
Look at
So
your
is
about to
that
sneeze.
clear? It has to start at the same height that it ends. Yes.
That's really confusing because hasn't all of our equations been like a cannon and then it hits the ground?
Yeah, well, I don't know. Do you remember the first time I drew that
Drew like a
cannon?
buried
I sunk it down in the ground.
So it's like,
Buried a cannon. So we
So-
really, well, what if it's hitting a man? Maybe the man is high as the cannon was to start, you know?
so it's like roughly.
Yeah.
Okay. Alright.
Yeah.
That makes more sense.
Alright, so yeah.
So, the range equation is used when the initial and final heights are equal. It can't be used in this situation or this situation. All right. So let's go on, and we had to do 3 in class yesterday. Oh yes, and then we started 3 practice problems. I thought that you could do them fairly well without any intervention from me, even though some of them, they gave you the range and asked you for the velocity, or they gave you the range and asked you for the angle. I think the angle one is the trickiest of all, so if you would, with me now, on the same day notes, on the range equation day 3, put in this example. We have a projectile at 345 meters per second, shot at an unknown angle, and the range is given as 7,512. So put in a quick sketch. And we're going to use the range equation, or do you want to use the long way? Which one?
Short way.
Alright, little joke. 7512 is the range. Normally we ask you to use the range equation to find the angle, to find the range, but we are given the range, so it's going to take the place of R. So we're up to V sub O, so that's 345. And then angle sine of 2 theta is not known, and since we're in meters, we're at 9.8. Sorry, don't need the line that long.
Wait, so the rate is 7,512?
The range, this is
Range.
Range.
Oh, okay.
This is the range equation. So the range is how far it goes in the x direction, and it was given. So I put 7512 all by its lonesome here on the left side where R is, and then I filled in these numbers like this. All right, so we have to solve, we're looking for the angle at this time, this one. Find the angle that it must be shot at. So, first step, mathematically, tell me, Emily, number 3, what do I do mathematically first?
Multiply by 9.8.
All right, so what is 7512 by 9.8? Is it 73,617.6?
Yes.
Alright, what's 345 squared? I didn't.
It is 119,025.
Alright, so mathematically, the first step is I multiplied both sides by 9.8 and squared the 345 right here and got this number.
Do you do like negative sign to get rid of that?
Yeah, I'll show you. Yes. Yeah. Alright, so now that's why I'm doing this one because it's the trickiest of it. Alright, Emily, number 2, divide both sides by 119,025. And what decimal do you get?
0.62.
0.62 equals sine of 2 theta. Now this is saying that there is an angle out there in the universe that when you double it, you get the sine, its sine is 0.62. So listen to that again. This is saying when there is an angle out there in the universe, when you double it, its sine is 0.62. So that's a little tricky there. You haven't really even had that in trig yet, but you can reason it through. Yeah.
I got something different for that.
Are you in degrees?
The angle that it is, that's not the angle. It's the sine of one angle divided by 2.
7,
Multiplied
3,
by 2.
6, 7, 3, 6, 1,
Sine of the angle that is multiplied by 2.
Divided by 1, 1, oh, it's
It could be the sine of 12,
119,025.
but
I think you have the second number.
if the
divided.
angle was 12
Yeah.
degrees,
Right
then
here.
this would be
Check
the
right
sine
here, Emily.
of
Yeah.
Alright,
24 degrees.
You're gonna have to divide by 2.
not yet. But
So you do the
So
sign.
what we're going to do is we're going to say, well, let's just say we want to find out what this whole thing, and we're not going to split this up.
You just have to get rid of
So
the
we're
sign.
going to say the sine of something is 0.62. Your calculator can tell you what angle has this as its sine, and as you said, it's sine inverse
Yeah.
of 0.62. But that is going to give us 2 theta, not theta. So that's the little
Then you have
tricky
to
part.
divide.
Then you divide. But you can't divide first. A lot of students say, well, let's get rid of this 2 in this step and make this 0.31. It will not work that way. So what is sine inverse of 0.619? Did someone get 38 degrees?
Yeah.
So 2 theta is 38 degrees. We don't care about 2 theta, we want theta. So we end up with 19. Alright, so a little
what
trick
about-
on that. Yeah.
So we're doing it because of acceleration 9.8.
Why is it 2? Or say that again?
The 2 significant digits. Is it because of 9.8 or?
I'm sorry, one more time.
We're using 2 significant digits.
Oh,
We're using
yes,
19.
yes, okay.
So is that-
I didn't hear the significant
Oh,
digit
no,
part, so I
sorry.
was like, 2, because it's there. Alright,
Yeah.
alright, yes, because of the 9.8.
Okay.
Very good. Alright, so yesterday I let you fly on your own through this problem. I just wanted to make it clear how those works when you aren't told the angle. So, to use this equation, sometimes I'm going to give you the range and the velocity and you tell me the angle. That's what I just did. Sometimes I'm going to tell you the range and the angle and ask for velocity. Sometimes I'm going to tell you the velocity, angle, and ask for the range. Alright, so on those OYOs, I think I had checked most people's. I had everyone checked out on that was here. So Alex, Hunter, and Brandon, sometime I want you to try those OYOs. They are OYO 4.5, 4.6, and 4.7. And show me your answers, or you can check them in the back of the book and tell me that you got them right so I can check you off. Alright. Then we were starting number 5, 6, and 7. We did it in class yesterday, so you need to catch up at some point.
I didn't finish that one either.
Alright, then we started in class 5, 6, and 7. Those were practice problems. I forget what page it is, but I will look. Would you tell me what your progress is on those? Have you
Miss Powell?
finished those? Alright, I need to check those. Yes.
Should we stop?
Yeah, okay, we'll stop. We'll stop
It's
now.
only
We're
been
kind of
10
at a
minutes.
point where we're going to practice a couple problems for just a few minutes and then learn something new. So we'll be back. All right.
Alright.